been in a swimming pool? Regular swimming pool, regular water. Yeah, right? You ever been in the ocean? Once in a while, right? When do you feel more of a buoyant force? When do you feel something lifting you a little bit more? Where? In the ocean. That's because it has not just regular table salt. It has lots of junk in the ocean, you know, all kinds of stuff, especially the Jersey Shore. But let's pour some salt in here and see if we can change the density of our liquid that's surrounding the soda down there that didn't want to float before. Let's convince him he's at the water at the Jersey Shore and see what happens. And yeah. Here he comes. There he goes. You're scientists, you have to make another assumption here. What do I have here? A bunch of water, right? Very easy.
Yeah, I knew these were bowling balls.
What do I have here? What do bowling balls do in water? They sink, huh? Are we scientists?
Yeah!
Are we scientists too? Yeah! Do the experiment. Good job, scientists. Very good. Hey! What's this? Is it the same size?
Yeah.
Yeah, right? How do you know?
Because you can see what it says.
You're ruining my... You're right. Very good. So, what's the difference between those two bowling balls? Density. Density, that's right. They're made of the same stuff, actually. This has a little more of a pocket inside it that's a little more, I don't know, air, a little different substance. So it's actually a 10-pound bowling ball, and that's a 14-pound bowling ball. 10-pound bowling balls can float. I didn't believe it until I saw it myself, actually. Who knew bowling balls can float? Now Mark's going to show us something else.
Technically, you can calculate, estimate the density of water with bowling balls. And if you want to get exactly, you can measure how much of the bowling ball is sticking out. And then you have to. Okay, well, let's bring on the balloon. This is another density demonstration. Why you don't want to do it all?
Our coating is the same.
Okay. Now this guy over here is a helium balloon, like you might buy at a circus. He has a density that is less than air, therefore he floats very nicely. And if I take my little weed killer here, this guy also has a density that's much less than air, except this guy floats much, much, much better. They're at least 4 times as well, because this guy is made out of hydrogen. But unfortunately, hydrogen likes to combine with the oxygen in the air and turn into water and give you energy, which is why they propose to drive cars with it and things like that. So when I light this guy, he should blow up. Okay? It just did enough.
Have it open and I put a little bit of water in here, okay, and it's heating up. So as it heats up, what do we get inside that can? Steam, right, a little bit of steam inside, and then what I'm going to do is I'm going to take it, I'm going to flip it over, I'm going to place it right inside this water bath, okay? So it's closed off from the outside atmosphere, and there's all this pressure from the outside, and it actually wants to go. Okay, all the water condenses on the inside, and what happens is that there's no more pressure on the inside to hold the atmosphere away from itself. So what is it going to do? It's going to rush. Can we try it? Yeah. Well, actually, let's do something else first. We used to do this with a great big can, but we found out it was a little undependable. So instead of doing the same type of demonstration with the great big can, what we're going to do is just use our regular vacuum pump to do the same thing. We're going to pull all the atmosphere out of this. and see what happens to this very large can. And this takes a little bit of time, so I'm going to start at the pole right now. We'll see what happens. What is this anyway? It's a 55-gallon drum, right? Not too small. It's not like a beer can you can crush on your head, right? Do it like that. Now we have the steam coming out of this one. I'll take it, flip it over. You can see how fast and how violently that crushes. That may happen to that one. Oh, we don't know when. You have to pull about half the atmosphere out of this can before it will actually crush. So we're going to scare Mark now because he's going to come over here and he's going to do some of the connection and stuff while it gets pulled out of that can.
What happened?
Buoyancy stuff we were talking about before. If you go over here to the rear tank canal and you see a nice duck floating on top of the water, that's because he has an oil gland that he rubs underneath his neck and spreads it over his feathers and he excludes the water, and he's a very low average density and he floats really well. On the other hand, if you see a cormorant, he will be floating with just his neck out of the water because they don't have that oil gland and their waters get wet, and so they can dive down to the bottom and get the fish very easily. Of course, the payoff is that when they come up, they have to stand around with their wings up like this to dry. That's what you can tell it's a cormorant, because it's standing around with its wings up like that. All right.